Good morning, YouTube. I wanted to show you my take on a totally off-grid system for a home and everything. And right here is the cargo container that I have everything housed in. So let's go inside. This is my 19.5 kilowatt solar array with 72 kilowatts of battery, a 25 kilowatt inverter, and a 20 kilowatt backup inverter, and a 26,000 kilowatt capable charge controller that can handle 26,000 watts of solar coming in. I got it set up as a 240 volt 100 amp charge controller. The solar array comes in through here. I got two cutoff boxes, one for the solar array and go to the charge controller, and this one, if I turn it on, I can actually come all the way through here to this box, turn it up, and power this inverter strictly off the solar panels and no batteries. I've got the 𝗟𝗘𝗧'𝗦 set up in a 2P72S configuration, and it gives me a little over 70 kilowatts of full charge, but I don't charge them all the way up. I have these 1 amp active balancers on them, and I really like them. They're 𝗟𝗘𝗧'𝗦s, if I'm not mistaken. And then over here is a charge controller, a battery charger, electric, in case I ever need to charge it off the grid. Let's go outside to the solar array, and I'll show you the solar array here. Now, I haven't had no problems running my whole house off the grid with this. I went with a higher voltage because it's so much less wire, less heat. So my solar array down here is set up at 346 volts. I got 72 panels of 270 watt solar panels. So I got 19.45 kilowatts right at. And let's walk over here and I'll show you get you a better look of the solar array. Now I just went with ground mounts because they're so much easier. I couldn't get the concrete up. My septic tank's right there, so to get a truck in here I would have to run over my septic lines. I wasn't going to do that, so I went with a ground mount company, and the whole solar array is grounded to the ground and held onto the ground by 18-inch long aluminum screws. I've had probably 60-70 mile an hour winds up here so far this year with them, and they haven't moved at all. So they work fantastic. I got a Disco 8 combiner box right there, which I really like. It's a totally waterproof system, and it's just so much easier to set the system up like this, where you don't have it way up in the air and everything. I put that weed barrier down, and once you put it down and you put it in the ground, and let's say it rains or anything, that weed barrier will shrink and tighten up, and it looks good. But that is my 19.5 kilowatt system, and it can produce the highest I've seen it produce. Right now it's just the 1st of May, but in March it produced 76 amps at 240 volts into the batteries. So it was doing about what, 16-17 kilowatts into the batteries. So it only takes, on a good sunny day like this, about an hour and a half, 2 hours to charge my batteries totally. Now, I live in a single wide mobile home, and it's totally electric. So, I've got the water heater. I live out here in the country, so I have a water pump. I got a water pump that runs off of 240. Everything is electric, so I have to have a big system to run. And I was looking at the 48 volt system and the amount of amps I would have to pull out. is 300 some amps, and that's a lot of amps and that's a lot of heat. So I went with the higher voltage, and I'm very happy about it. It took me about 4 years to resource, to study, and to figure out how I wanted to do my system. It's been running flawlessly off the grid now, and I've been having it run for about 2 or 3 weeks now, and I'm very happy with it. But I just wanted to give you my take on how a totally off-grid system should look like. And I built this whole system. Now, this is a one-trip container I bought for $3,500, and then about $400 delivered all the way up here. But they're a lot more expensive now. But I got lucky. I found it on eBay, and very happy about it. I built, the walls, and I insulated it. And you want to insulate it for the winter time and the summertime to keep it cool. But I just installed an AC in it for the summertime. And this little AC, like right now, it is 71 degrees in here, and I want to keep it to about 72, 73 degrees. And this little AC unit does fantastic. It takes the hot air, and I drilled a hole in the ground, in the floor there, and it just takes all the hot air out, and it feels so good in here. And during the winter time, I put a little space heater in here, if I can find it, right there. And this thing, if the power trips and goes from grid to off grid, it will just start back up. It's not like the other ones that you have to come back out here and turn on. So if it's freezing cold, I don't want my system freezing up because I didn't come out and turn on my heater. But this 25 kilowatt, if it's running, it keeps this whole thing warm in the winter time anyway, so I don't worry about it. But I have active balancers, so that means it is charging and discharging all the time. So if this thing drops below freezing in here, and those batteries get below freezing, and those are active balancers on, this is going to destroy my battery. So you always got to have a heat source and air conditioning, and just keep your system, cool and warm all year round with the temperature it needs to be. But if you'll go ahead and subscribe to my channel, this is my first video, and I'm sorry it's not that great, but I'll go through every component and show you how to build this system, show you where you can get the inverters and the charge controllers and everything if you want to build a totally off-grid system. If you're going to do off-grid, a 5,000 kilowatt inverter or anything like that, it's going to power your lights and little things. You can't run this like me. I can go take a shower, hot water heater comes on, I can run the stove, the washer, the dryer. I can live life normally, all right? And that's what you want. And for about, well, right now, I bought those batteries for $7,500 delivered and everything. Right now, those same amount of kilowatts, it's going to run you about 11 grand. It's gone outrageous. But the rest of the parts haven't gone up that much, especially the solar panels. And you could get out doing this, if you did it yourself, for about $35,000. You could be totally off the grid for the next 20, 25 years and not have to worry about, well, I can't turn on the dryer because it's going to trip the, overload the inverter or anything else. Now, I did it this way because the wire is so much simple. Let me show you. All you really need, I got the boxes coming in to turn off your solar, and I got them at the solar panel, so I got two ways to turn off the solar power. And all you really need is the line going to the charge controller, to the disconnect from the batteries, and then another disconnect from the batteries to the inverter. This is extra. I also got AC in here for AC bypass. For the inverter, it has AC bypass. If I want to turn it off, it switch automatically to AC. It'll take 100 amps. All right, I got 200 amp breakers at 240 here, and at 100 amps I can still run my house no problem. So this inverter, instead of having 5 on the wall or anything. You have one inverter. Now I bought the 20 kilowatt and I need the extra 20 amps because of the furnace and everything else. So I went ahead and ordered the 25 kilowatt. But you know, if anything happens and I need to work on this, I'll switch to the 20 kilowatt. But these inverters are supposed to last 15 to 25 years. You can hear how smooth the fan comes on after it starts heating up and it runs. So you don't want to have this inverter in your house, all right, because it is a little noisy. But as you can see, I'm running about 244 volts right now. The batteries are charging at 40 amps, and I'm putting 241 out. And I'm running about 4.8 amps at 60 hertz. And the charge controller, let's see if we can light this thing up. Charge controller is putting out 39 amps, and I've only got it set at 40 amps right now. I found out that the batteries like about 40 amps. I can charge it fast, but why need to? They're almost fully charged, you know. Here it is about 11:30 in the morning, and after all night of running, the battery's almost charged. So it always goes good to go big. If you're going to do solar, oversize your system double what you want it to do, or you're going to be running back and forth resetting your inverters and everything else. You're going to be draining your batteries. So if you're going to do the system, always, you know, double, triple your size that you need. Like I use 20 kilowatts during the summertime at night. I use 30 to 35 during the wintertime. And I have double the battery bank. So I only use up to about 50% of my battery bank, which will extend the longevity of my batteries, you know. And you don't want to totally charge them all the way up and deplete them all the way down. It's just like anything else. You run it at full throttle, it's going to wear out. So if you can get it to where it runs 50%, it only drains your LiPo4 at 50%, your battery's going to last 20-25 years. I mean, I don't know about the shelf life or anything else. I just know that charging and discharging those batteries should last me, you know, up until I'm in my 70s. So I'm going to go ahead and start my channel. I'm going to get me a you know, a selfie stick and some props to put the cameras on, and so it'll be better, you know, videos and everything. And then we'll go through one by one of what I did with everything. If you want to develop a system like this, it's just so much easier, so much less wire. Before I go, let me show you how easy this wiring is. I mean, you have one line going into the charge controller and then to a cutoff box and to the batteries. Now I could have come from here and went to this cutoff box, but I just went ahead and went down and connected my batteries there. So I got two connections there I could have got rid of. And then from here, it would go straight into your charge controller, unless you wanted to run strictly off the solar panels. And in a doomsday scenario, I would want to run just my solar panels if something happened to my battery. At least I still have electricity. And during a good day, I can run the house normally just off the solar panels, because this thing has huge capacitors in it to take the surges and everything, and it works fantastic. So please like and subscribe my video. I promise my channel, and I promise the videos will get better. I'll stop all this hand movement and everything. This is the first time I've ever done a YouTube commercial or video, and we'll go through step by step of where you can get resources and build your own. All right, for now, my name's Mike. Take care, everybody. Bye.